for sure, for sure. Yep. Hi, everyone. Is everyone hearing me over there on the back? All cool? Okay, so let's kick things off. First off, so you found some drinks probably scattered around first. Second, be sure that the pizza will arrive on time, so probably in an hour. Then let's start with a question. Who was with us last week at the previous engineering night? Cool. Special welcome to you. And a warm welcome to all the others, by the way. Thank you, Alison, from the AI user group, for welcoming us here in this beautiful space. And thanks to Rahul from the MLOps community, who will give a few words to introduce you to their community.
Hello, everybody. Welcome. If you guys have attended the MLOps community events, you might know me from them. My name is Rahul. I'm one of the local organizers here for the MLOps community. Yeah? Okay. Well, there'll be a slide with a QR code, and you can scan and all that good stuff. Maybe I'll borrow more time in the meantime. So the MLOps community is like a global community. We have a Slack channel that's like 30,000 people-ish. And the MLOps community, what they do, or what we do, is we're concerned with how do you ship machine learning and AI to production. So it used to be how do you train machine learning models and ship them. But now, obviously, lately, it's been all Gen AI. A couple of months ago, we had an amazing event in San Francisco. It had about 500 people we checked in, so we are going to throw one more in like September. So if you're attending, great, you're in good shape. I will be sending you another invite in a couple of months. But what we have for the community is we have a Slack channel that's really active. So you have a question about like, oh, how do I make this model work on Kubernetes? Or if you want to ask a question like, what does observability look like for workflows? That's your Slack channel to ask your questions. Demetrios hosts amazing podcasts, and they're like plenty of good videos to watch online as well. So scan the QR code, and you should be good. I had 1 minute, but because the slide was not up, I borrowed some time. Sorry about that. I also wanted to say thank you to the Dust team to organize this amazing event. As you know, the MLOps community has been doing a lot of events lately, but these guys are here from France. So I'm super stoked that they're here. Amazing team. You should definitely chat with them right after. There we go.
Thank you. Yep, that works. Who knows Dust already? Okay. So in one sentence, let's be quick. Dust is a platform that allows everyone to build their own AI agents in minutes, connected to their data and tools, powered by leading AI models. So in practice, from ID to agents, you just start giving your agent some instructions. You choose the tools you want your agent to use. So literally, to increase performance, you want an agent that does the job. So focusing agents increases performance. So you don't want an agent that searches the web every time you ask for the office Wi-Fi password. So this is where all the MCP server fun is happening as well. And then you give your agents its wings. So how it's called, who can edit it, who can call it, where can people use, and the agent, right? Is it on the Dest app? Is it on Slack, etc.? And boom, your agent joins the fleet of other agents used by the company. So if you want to try it yourself, you have a QR code scattered around the room. So smash that QR code, and instead of 2 weeks, the regular 2 weeks free trial, you will enjoy 2 months for free. It's on Dest.tt otherwise. Then if you want to come join us and build the future of work, we are hiring in every team in San Francisco, in New York City, and in Paris. So come talk to us as well. And now I am thrilled to welcome Kriti.
Hi, everyone. Please raise your hands if you've used an AI assistant in the past week, like Siri or ChatGPT? Okay. Now, raise your hands again if you've been able to execute an end-to-end goal with a lot of steps where the agent was able to self-correct. Now, this gap in hands is where the opportunity of billions of dollars lies. And that's where we are with the AI agent. I'll quickly walk you through how we came to where we are. So quickly talking about the pre-generative AI era with the classical programming systems. Here, the humans wrote detailed, incredibly detailed rule books for computers to follow. This is Eliza. It's popularly dubbed as the grandmother for current AI chatbots. Built at MIT, it could have a conversation by doing something brilliantly simple, turning your conversation into questions by following a simple pattern. It established our fundamental paradigm, AI as a reactive responder. How many people here recognize this person? Any chess fans? This is world chess champion Garry Kasparov. Deep Blue, in 1997, used pure computational brute force to compute next few moves and defeated him. In 2011, Apple brought this technology to the masses with Siri. Suddenly, millions of people worldwide had AI assistant in their pockets. But notice the pattern here. These were assistants, not agents. They waited for commands, followed rules, and gave responses. So the problem here is they were brilliant in their narrow domain, but completely helpless outside. Eliza could not play chess, and Deep Blue couldn't have conversation. Every new task required human experts to hand code new set of rules. And there simply weren't enough experts to program every possible scenario. This led to our deep learning revolution. So everything changed in 2012 with a breakthrough called AlexNet. Instead of programming rules, we could show computer millions of examples, and they learned from data, not rules. How many people recognize this board? This is the Go game. Now, a mind-bending fact here is the number of possible legal moves in this game is of the order of 10 to the power 170. To put that into context, the number of atoms in the observable universe is 10 to the power 80. Brute force was simply impossible. This is from 2016, when AlphaGo defeated Lee Sedol. But a new problem emerged. We just traded one limitation for other. Sure, they could learn themselves, but they were still incredibly narrow. This leads us to our level 3 transformer and attention mechanism, brought about by this paper. Most people in the audience would have probably read this. The transformer architecture didn't just incrementally improve AI, it fundamentally changed how machines process information. Instead of reading text sequentially like we do, transformers could pay attention to every word in a sentence simultaneously, and in a long context, figure out the exact portions which might be relevant to the current context. T5 from this era showed us that we could frame several AI tasks as text-to-text problem, and then OpenAI Clip could connect text and images, and vice versa, to have cross-domain understanding. This leads us to our generative AI era, up to 2022, we'll talk about, and that was just an era of plain LLMs and chatbots. GPT-3 launched in 2020 with 175 billion parameters. But that wasn't the real breakthrough, the size. It was actually the adoption. In November 2022, the ChatGPT's launch broke the internet. 100 million users in 2 months. This was the fastest adoption of any technology in human history. Everyone had a personal writing assistant in their browsers. And these LLMs were genuinely fantastic at that. But here's where we hit the wall again. I can ask this ChatGPT-1 to write an email to my team about my upcoming vacation, and it'll craft something very professional. But if I ask how many vacation days do I have left, that's where it fails completely. So we see two fundamental problems emerge. One, despite being trained on the entire internet's knowledge, it knows nothing about my company's HR database, my personal calendar, or my employment contract. It's incredibly smart, but completely isolated from the real live world. And second, these systems were entirely passive. They waited for you to ask, then respond, and then waited again. The obvious solution seems simple. Connect these brilliant language models to external tools and data sets. And this worked, well, sort of. You could possibly be connected to APIs, tools, data sets, and hard code. So if someone asks about vacation days, query the specific database. But then I ask, did my manager approve my leave? And that's where we fail again, because I could not connect it to Slack. So each new question requires a human to manually configure a new integration. This brings us to where we are today, the emergence of true AI agents. Now, the key thing that's different from the AI workflows here is basically who's taking care of the control logic. If it's a human and programmatic, it has very little autonomy. It's a fixed flow. But in AI agents, we come closer to more variable flow. Essentially, the key goal here is it's still the same setup, but the brain has moved from human to an LLM. Instead of human thinking, an LLM is made to think slowly, break a complex goal into small tasks that it can figure out through the same things that were already there, the tools, the APIs, the memory. These are the 5 defining characteristics of an AI agent. 1, goal-oriented behavior instead of tasks. You can have bigger problems for the LLM brain to solve. 2, tool orchestration. They can seamlessly coordinate between several tools, email, Slack, data sets, without you pre-programming every connection. Environmental awareness. They can perceive when conditions change and adapt accordingly. These are being used in disaster recovery programs where they can figure out from social media if there have been too many tweets about possibly something, and also have, say, weather and camera integrations to figure if something is abnormal. Next is memory and state management. They remember what happened yesterday and can build upon previous interactions. But most importantly, self-correction when the first approach fails to try something else. Take Devin, the software engineer. You give it a GitHub issue, and then it'll write code, test, debug, and submit a pull request all by itself without human intervention. Salesforce Agentforce can handle customer service inquiries from start to finish. There is human in the loop, but it's only when necessary. Now, from here, even our best agents essentially are just smart individual contributors and struggle with cross-domain collaboration and reasoning. This leads us to multi-agent systems, which is the current cutting edge and what possibly my next speakers will start speaking about. These are collaborative agent with role specialization. Instead of one super agent trying to handle everything, we're building a team of specialized agents that work together. The most exciting developments that are happening right now possibly is one, reliability. Current systems have good accuracy on complex tasks, but enterprise systems need human-level reliability for mission-critical work. That gap between impressive demo and I'll bet my business on it is where billions of dollars are trapped right now. We're witnessing the largest productivity revolution since personal computers, but we're not there yet. Regulation is catching up fast. The EU AI Act takes effect this August, and it requires transparency and human oversight for high-risk AI systems. Companies deploying agents will need to prove their systems are auditable, explainable, and safe, things we are struggling with right now. So what does this mean for you? And what should you do with this information? So if you're a founder, AI engineer, or just someone trying to understand where this is all heading, here's the critical move. First, invest early in experimentation. Companies that start building with AI agents today, even the imperfect ones, will have massive advantage when the reliability gap closes. 2, embed these products deeply into user routines. AI products shouldn't just solve problems, but they should become so deeply integrated in daily workflows that it's painful for users to switch. We're witnessing the largest productivity revolution since the personal computers. Personally, I'm most excited about embodiment, that is bringing AI agents into the physical world through robotics, where we are not just digitalizing workflows, but reimagining what our world and work itself looks like. The choice isn't whether to embrace AI agents, it's whether you'll be leading this transformation or scrambling. Thank you.
Well, while Gian is getting all set up, I want to emphasize how special this moment is because our friendship goes a long way. Oh, yeah. Like last time we gave a talk and shared stage was back in 2016 in Berlin. So since then, almost traveled all across the world. And now I'm very happy to get reunited here in San Francisco. And Gian, on to you.
Thank you. Hi, everyone. It's not going to be super technical. I apologize since the very beginning, but hopefully it's going to be interesting. I'm part of Replit. It's basically the world's first coding agent. And I've done basically everything. I think the slide says that I'm core contributor. I think the only role I haven't had at this company has been like HR. Replit is like basically a place where you can build literally every kind of piece of software you ever want. You can like be a doctor and write full stack applications. You can write email validation systems. You can write custom timers. You can even like trade if you feel like trusting it. And it's like the place where you have a text box and you hit enter and you get a URL back, basically. And what I will try to do in the next 15 minutes is show how I believe this is like a fundamentally different way of building products, growing companies, and approaching, let's say, startups in general, in the tech industry. I believe it started a few years ago. I think we're now seeing the actual full extent of it. And I think basically anyone that wants to build using AI will basically split into groups, those that get it and those that don't. To see why that is the case, I'm going to need to start from, let's say, how we built tech products before. Let's take, Netflix or Instagram. These are products that are fundamentally built on top of software, right? Code. And code is a function mapping some inputs to some outputs. You can think of products very much the same way, right? You can have like a set of constrained inputs mapping to known determined outputs. You have a set of features, sending a message, liking a story, following an account, and every time the user take the action, it will result in a very determined output. We know what will happen, right? Everyone here, engineers, you can write end-to-end tests because of this reason. You can specify an input following that account. Every single time you run the test, unless your CI is fucked, you will have like the same output. That's the entire point of engineering. Let's call this function f. Let's have the n being a limited set of actions and m being the result. If you accept this premise, this, let's say, framework of seeing tech products through this lens, well, at that point, you can understand where a bunch of stuff that we do as an industry where is that coming from? I'm sure most of you will be familiar with this dashboard. This is like what engineers obsess about. This is typical Datadog SLO dashboard. Your goal as an engineer is to have everything green, mostly like what we call the 3 nines. You hit 100%. Why that is the case? Because if your job as an engineer is to write that function and have that function mapped to M, well, your role is every single time you call F, that yields, M. 100% of the time, reliability is basically the goal you're optimizing for. And so therefore, you take a cumulative, layered approach to building things. Every senior engineer here will know that, refactoring, you take it very skeptically. Why? Because like, if it ain't broke, don't fix it. Again, typical engineering 101, you build on top of what came before. And why? Because, if reliability is the goal, like we need to be very tactical and careful when touching the system. That also is the premise through which you can see classical product management in like typical PMs or designers even, right? Like if the function of the product N is like actions that the user can take, and M is like, I don't know, the user 30 days later is still using the same feature, well, you're optimizing for another ratio, in this case a funnel, a conversion funnel. It can be also like a retention funnel. The point stands. You have 2 numbers that you can count, N and M, and you basically take the ratio between the 2 and you try to, you strive trying to reach 100%. And that's the reason why, we have funnels like, tools like Amplitude and Mixpanel, et cetera. We have set of features, we have known metrics. And, you can make the same argument about most other functions in a typical startup. Marketing is about like increasing the number on top of the funnel. Sales too. Sales tries to squeeze as much like people through this funnel, et cetera, et cetera. My argument is that when this guy dropped, everything changed. This guy being 6-to-6 model, most MLE here will recognize it. I believe that this is the moment when we start productionizing a piece of technology that is like very different. Because the encoding part is infinite. Well, we can argue that it's not. Practically it is, meaning we do not control the input space. You can type as many words in there. The combinations are practically, let's say, very, very large. And so we don't know what's going to be coming from the other side. We have infinite things we can put into the product. Think of ChatGPT, think of Replit, think of like anything, really. You can put as many things in there, and the product will reply something. Now, you may make the argument that when this happened, well, it's machine translation, so it's not that big of a deal. But when we started scaling that up, what the previous speaker was referring to as like, the scaling law of the 2017 and onwards, well, we are seeing emergent properties. And these models, well, we don't even know what they do anymore. And to top it off, like the final nail in the coffin is that you try to put the same input N. It's an infinite like number of things you can put in there, and you get 2 different outputs, N different outputs, infinite outputs. It's basically mapping that function to a probability distribution. It's no longer just a point in space. It's literally like a probability distribution. So that's the reason why I like to think of this as more like a quantum shift, moving from classical physics to like this probability distribution. The characteristics is, first and foremost, this is the thing that honestly blows my mind the most. We do not know how these things work. That's the reason why companies like Anthropic are obsessed with safety. Like, we have no idea. These are like aliens. We close them in a room. We come back after spending $100 million and like 3 months of training time. We have no idea what they do, right? Even the labs themselves don't really understand their behaviors, and they're leaning on like companies like the one I work for to understand, what are these models capable of doing. Variance, the thing I was mentioning before, the stochastic element, right? That to me is like so interesting, is a feature. You want that. It's like the reason why we call sampling and temperature like the creativity of the model. It's what makes the model smart and what allows you to capture like a much wider market. Like no code was like very specific 10 years ago. Now you can like literally type anything. The problem is like users don't like it. You start asking like on Cursor, hey, fix it, and it's not gonna fix it, it's not gonna make it worse. Users get very mad from this. And the reason why that is the case is because the output is stochastic, but every single time you roll the dice, you pay quite some money, deterministically. So you have like certainty of paying, which is like paying, and you have uncertainty of output, which makes this quite an interesting design challenge. So my argument here is that we're moving from a world, the tech world, that is very much engineering-driven, and towards a world that is much more like empirical, and it takes a scientist. And that to me is like the main reason why Replit's president is literally a scientist. The engineering tendency to deal with these models is, just slap an SLO. We're gonna like rein the model in, we're gonna add constraints, we're gonna like add blueprints, and make sure we slam as much information in the system prompt as possible, and we try to rein it in. And the problem when you do that, and you follow like the typical engineering rules, you end up nerfing the model. Like you're gonna kill its creativity at best. At worst, like you're gonna lobotomize it, and it's not gonna work as well anymore. And so at that point, you can no longer strive for that 100%. It's not possible. Your role is to manage the uncertainty. What is the uncertainty here? Well, there's like some kind of level of acceptable unpredictability that you must be comfortable with that keeps the model expressive. So you can go to Replit and like literally type whatever you want within some boundaries that are way looser than your, let's say, typical engineering tendency would feel comfortable with. And so what this looks like in practice, like in terms of actually developing Replit's agent, this is what like the typical AI engineer Replit looks at before like doing anything, deploying anything. This is like a lot of A/B testing in production, a lot of evals before that, sampling from the population to build the eval set and keep it fresh. You need to have a rigorous system that is very much more sophisticated than typical A/B testing on Amplitude or whatever tool you use in order to make sure that you can progress, reining this in like this uncertainty and making sure you can control basically this probability distribution. And the thing that blows my mind the most is that, new model, everything, you need to scratch everything and reassess every single assumption from scratch. Typical example I usually bring up is in when Sonnet 3.7 dropped in February. After 3.5, we migrated it, right? And that's the moment we dropped Replit Agent v2. That was like a complete re-architecture of the whole thing. We threw everything away, rewrote the entire thing in 3 weeks. Sleep deprivation, the whole thing. And that was needed because like 3.7 had a completely different behavior with respect to 3.5. And this is very much against the typical intuition of the engineering mindset, which by the way, I'm totally like part of. And that's like the repercussion is go deep into like also the PM space and like the design space. At that point, you can no longer think in funnels because like, someone will text in the Replit agent, hey, I want like a, I don't know, tracking, food, diet, whatever. And then like they will start asking things that are over and over more specific. And at some point, the trajectory, what we call the trajectory, will become basically unique. And so you need to have advanced data work and heavy data engineering in order to make sense of it, in order to understand what users are even doing in the first place. Are they successful? Are they not? Are people coming from a certain channel profitable, or are they not? And that's like very much boring, tedious, but very important data work where you have like trajectories of like a bunch of IDs chained together and a bunch of tokens that you need to basically make sense of and classification. What this ends up happening at the end like is basically having data almost like as an operating system. That's the way I personally think of it. We used to have in tech, I'm sure most of you will be familiar with like, siloed data, let's say tooling. So you have like product that is like Amplitude and Mixpanel. You have marketing, which is like, I don't know, Facebook ads and like CAC, CPI, et cetera, et cetera. You have engineering, but like observability tools like Datadog. And now like, and obviously finance, counting money, I don't know, with Excel, I guess. Now you cannot afford to do that anymore. You need to have a unified system that shares the entire thing like beneath the company. Because like the moment an engineer starts touching the prompt, it has repercussion all the way to the margins for the finance team. The moment the marketing team starts like investing in a different channel, they will acquire certain use cases that are like completely different. And engineering at that point will freak out because like, hey, the product doesn't work anymore with this kind of users. And so at that point, you need data to be much more unified instead of like the siloed approach we have today. And I'm gonna close, SF, we've been here, And we know that every single time there's a new piece of technology, every time we hear this time is different, hype is a big deal here. I want to argue that this actually is different. It's ontologically different because we're moving from like a deterministic world to like one where we don't control the piece of software we are using anymore. And this is like very much technical, in the way we build the product, epistemological way of like knowing things, how the product even works in the first place, what users are doing, and finally an organizational change, an organizational shift, because the way we do our job, the playbooks, the roles are, at least to me, very much changing a lot. So this is fun, and I'm really happy to be here at the Frontier video. Thank you.
Okay. Awesome. Up. All right. Thanks everyone for coming. My name is Jules. I'm a software engineer at Dust. And tonight I'll be talking about building distributed agent systems and how we actually did it at Dust. But to start, I'm going to rewind a little bit and to put some context. So I guess this rings a bell to everyone, maybe not the youngest of us, but that's how back in 2022, 2023, the APIs, OpenAI APIs look like. So you would just basically give chain a bunch of messages, user assistant messages, and then the assistant would reply back with a response. So basically here, you're stateless, synchronous, you get a response within seconds. That's it. Then the next big revolution was that we saw tools appearing. So API stays roughly the same, just here we have an extra parameter where you would basically present the functions that you give to the agent, and the agent would okay, let's call it assistant for now. So the assistant would actually answer with the tools to execute, and then you would loop over them, execute them, and wire back everything to the assistant. So here, still the same. We are synchronous, stateless, and my point is that now, and bear with me, that's the last slide with code. Yeah, so now, and very recently, what we started appearing was actually reasoning. So it enables a bunch of new use cases because assistants are actually way smarter. But the problem with that is that it takes way longer. So let's say you're doing a deep research task, then it fails after 15 minutes, then what happens? You just need to retry everything. You lose some money, and also if you're actually user-facing, then from a UX point of view, that's very bad. So my whole point here is that we basically need to change something. So we are actually trying to have modern agents run on traditional web architecture, but I don't know if you remember, but basically the second slide introduced a need for orchestration. So we need to orchestrate tool running, and then the third slide actually introduced the need for persistence. So we need to be able to actually keep track of what's happening. And with that in mind, at Dust, we decided to redesign our infrastructure. So the main three challenges that we had back then was that, so deployment here this is very specific to us in the sense that our repo is actually a mono repo, meaning that the front and so the web app code and the agent code are actually very tied together. So meaning that if you deploy the front code, then of course you interrupt agents that are running, and then for users, this is pretty annoying. The second challenge here, idempotency, which means that, let's say you have a task that is a tool that is send invoice, I don't know, it's part of a workflow, your workflow fails, then you retry it, and then what happens? You basically send that invoice twice, which is pretty annoying. So this you basically want to avoid. And the last one is the scale. So now that you have agents that are actually able to spin up sub-agents, you need to be able to orchestrate them and also give them resources. So those are the 3 challenges that we have and that we actually had. And the solution we came up with is actually very simple. So that's where everything lies. So it's a while loop, which I like to call it the orchestration layer. And it's it can be divided in 2 blocks. So the blue block is actually the brain of the layer, meaning that that's basically here that the LLM is going to tell you whether you should run tools or it has enough information and now can answer the user. And then the second block that we see here, so the yellow block, is actually just like running tools in parallel. So if you think about it here, the yellow block actually solves the problem of scalability, but it doesn't solve the first 2 problems, which are our deployment problem and the idempotency. Okay, so that's now where the things get a bit more tricky. So we had to come up with a versioning system to solve that idempotency problem. So here, if you look on the left side, we have 2 interconnected tables that are actually the backbone of our distributed coordination. So you have the agent step content on the left, which stores the planning output from the brain. And then on the other side, you have the agent actions, which stores the tool execution results. So each table, if you can see here, each table actually shares a versioning structure. So you have the step, the index, and the version, which are basically used to track retries. And that's where the magic actually happens. So it prevents duplicate execution. So before we run any tool, the system checks if a successful version already exists. And if it found a successful one, then it actually just returns the cache results. And that means that basically network retries, deployment interruptions, or infrastructure failure, whatever, that's no longer going to cause any duplicate side effect. So here, basically, what I want to say is that the version acts as a sort of safety lock, which allows multiple attempts and still maintaining like an history of what actually happened. Yeah, so the beauty of it, like at least what I find actually quite cool about it, I didn't design it myself, but this is actually quite cool, is that there is the versioning approach enables like distributed coordination without actually having the brain and the hands communicating together. So the tool tables are actually a protocol where brain and hands communicate through the database state rather than messages. So let me explain how that basically looks. But like, so when the brain decides to execute a tool, then it writes those decisions to the agent step content and reads the latest state results from the agent action to understand what has already been accomplished. And in the meanwhile, so the hands read their instructions from the agent step content and write their results back to the agent actions. So this creates sort of a continuous feedback loop where each component always accesses the latest state from the other one. So the way we design this versioning system actually ensures the coordination during failures, meaning that when the planning activity actually retries, then it reads the maximal version from the agent actions to see which tool have actually completed, and then writes a new version to agent step content with the updated decisions. On the other side, so when an execution activity retries, it reads the stable planning decision from agent step content, and then the attempts to fulfill it, so to write a new version actually in the agent action. So here, basically, the database becomes the single source of truth, and every agent activity coordinates through this shared version state. I'm going to get a simple example. I'm going to get an example so that we try to understand it. But let's say we have a simple use case that is a user wants to send an invoice to company A. So what's going to happen? So we start with a planning phase. So the user sends his message, then the workflow begins. We trigger this run agent workflow. And the first activity, which is the plan and respond activity here, no, that doesn't, okay. The plan and respond activity receives the user request. So the agent analyzes it, and it determines that, okay, to send an invoice, I actually need to know the amount, the invoice amount for company A. And once I have that, then I can actually send that invoice. So this planning decision is going to get stored in our Postgres database, which, as we saw before, the agent step content. And now comes the execution phase. So we have the plan established, and then the workflow moves to the run tool activity phase. The agent executes the first tool by querying the database, and then this succeeds. The results get stored back in Postgres, and then that's basically it. So we're done with the first round. So now the actually interesting part is that the workflow loops back to the plan response activity, which determines that the next step is to call the, let's say, Stripe API, and then that creates a sort of checkpoint in where we persist the workflow's progress. So now that we have this, then the next step is to send the invoice again. But this time, let's take an example where it actually fails the first time. So let's say that Stripe is experiencing outage, or we have network issues, or whatever. And then instead of retrying the entire workflow, the cool thing is that temporal. So we use actually temporal. Yeah, I forgot to mention that, but we use temporal. It's just a workflow orchestrator, as any workflow orchestrator. But the beauty of it is that temporal is actually going to retry the run tool activity, and when it retries it, it's going to check the DB to check the version, and sees that basically last time we made a call to Stripe, it didn't succeed. So it will create a new version and attempt again, and let's say this time it goes through, then it stores back the results in Postgres. So what's make this architecture powerful is how the plan and response activity work actually with the run tool activity in a sort of continuous loop. Each iteration loop represents a step in the agent reasoning process, and with durable checkpoints between each step. So through this workflow, we can actually handle very complex scenarios with multiple tools running simultaneously while maintaining the proper coordination. So as I said before, the DB actually acts as the distributed memory for the whole system, and it allows activity to coordinate without direct communication. And then the temporal workflow provides the orchestration logic. So we don't need to care about anything, temporal does it. And it ensures that the steps execute in the right order and survive any infrastructure failures. So we went for that option, so that's the design we ended up with, but then we also explored a bunch of other solutions. We started with a container-based solution, so I don't know if E2B rings a bell to anyone, but we started exploring that. But the problem with this is that container orchestration and resources allocation are actually very challenging. So you're going to spin up a bunch of containers, then you need to allocate resources. I mean, most likely going to end up with resources starvation, or like basically wasting resources, which is quite tough. And on the other hand, the storage part is also quite complex. So we discarded that option. Then another one, which was actually very appealing, was a rainbow deployment, which is I think how Anthropic does it. But the main problem we have is that it's because of our monolithic architecture, which is, as I said before, like we have the agent execution and the web applications that are actually the same code base. So when you run an agent like on an old code, and you don't want to have the front-end part that is actually executing on the new one. So that was tough for us. And then queue system, why not? The thing is that there's a lot of infrastructure that you need to maintain, message queues, worker pools, like state store, whatever, which is, I mean, in the end, it's basically reinventing tuple. So I'm not saying temporal, but like this is actually very cool. And so for us, we ended up using it because we are already using it at scale, in the sense that all our connectors are actually working on temporal, so no new infrastructure needed, way less complex, and yeah, that's how we ended up using it. So thanks everyone for your attention, and I'll stick around if you guys have any questions.